Hi, let's talk some physics, new physics, entanglement, and then let's talk about the mathematics for it and consequences and religion, things that interest me. I think you'll find interesting. What we found out is all things communicate, uh, and when they do, they create four species of fields. Here they are, right here. See if I can see that. All right. A perfectly elastic line of communication, just a basic field. Okay, now the character or the rate density of this field is formed in a Pythagorean relationship. A squared plus dA prime squared, square root of that equals this rate density. All right, now A is the locale, the rate density of this locale, and dA is the distance between partners. Creates a stationary field. All right. Now, if a symmetry is found within this field, a new field is created, and it's called a semi-inelastic line of communication. The rate density is also, in this field, is also created from the locale and the distance in this Pythagorean relationship. All right. Now, this rate density is going much faster than this one. This one is actually for a product of the p log. You know, it's the speed starts at this rate, and then because of distance itself is applied, it's even faster. Now, if symmetry is found in this psi lock, an I lock forms an inelastic line of communication, and of course this rate density is even faster, and yet the effects of it appear slow. Okay, a standing wave phenomena is kind of created. All right. Now, if the I lock interacts with the psi lock, you get a shifting kinetic effect field. Okay, and this is very robust, and this is what we may attribute to being alive. This back and forth shifting and has different characters and looks different. Could be long, 20 bleeps or presences, and then 20 this way, and then 20 this way, and then 20 this way. It could be very fast or very slow. It could be one field production, and they could have an hourglass shape. Anyway, et cetera, et cetera. It's unique. It depends on the distance and the character of these fields, these ILOC and SILOC fields being produced. But, you know, just briefly, life formed because of special properties of elastic communication or entanglement, robust entanglement. Spheres, circles, have special properties, then they encourage entanglements. And what that means is that just by being the same, or a circle or a sphere of similar elements, then entangle, and they do so at a rate of probably, I don't know, we measure lightning at 25 times per second. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6 per second, and then 1 yen, 2 yen, 3 yen, 4 yen, 5 yen, 6 yen. That fast. So things are communicating very, very fast. All right. Now things communicate across space or very close. Okay. And so everything has the ability to communicate with everything else, all right? And that's why we have notions of conservation of mass and energy. Things are just always communicating. If you put something in motion, it's going to have a certain motion, and the things that you communicate with are going to keep that in motion, all right? Anyway, but it's just kind of it's false. It's not correct. It's an imperfect way to look at nature, and it didn't allow us to do anything but burn things like gas and destroy our atmosphere in the process. We didn't really understand, but now that we do understand, like I said, with spheres, they encourage entanglement. So a sphere with anything with like elements then entangles, and it creates 1, 2, 3, and then 4 species of fine structure fields. And this last field that's produced shifts, all right, and it's what we understand to be energy, and it creates atomic motion. So inside, you know, a sphere of oil or simple atoms in the beginning creates this enormous electrical activity and attracts other atoms, and then life can evolve. But it started out with this shifting, and I think that even in ourselves, this shifting occurs. We are a product of our own evolution of cells. We have this shifting presence within us at the cellular level for sure, and then in spheres, so in our cranium and in our ocular, our eyes, we have natural complex fine structures being formed, and so we have this shifting presence. And to say someone is alive or feeling alive may be this intuitive search or intuitive understanding of this shifting presence. Anyway, so this robust entanglement allows us to understand maybe then what life is itself, and forming out of special properties of spheres. Anyway, and that also, by the way, explains black holes. Things are not just absorbed into black holes and disappear, traveling faster than the speed of light. Of course, black holes are just complex, fine structure events taking place, and of course, we and light itself will be able to travel much faster than the speed of light, but they're not consumed and destroyed. It's just something that you would, if you entangled, you would pass through and not be destroyed. You'd maintain your autonomy. Anyway, this theory of robust entanglement allows us to form or watch the formation of matter. Okay, and what you have is an elegant geometry that forms over vast distances of space. And so this is important, but that we'll talk about in a second. But let's look at it, how it might form. Okay, and these are complex elastic networks. Okay, now watch. Let's see if I can get it. All right. So you start out with just a simple, two wavefronts, communicate. Okay, create an entanglement. Now, as we conceptualize it, this wavefront kind of gets more dynamic, okay, here, and then gets more dynamic. And what happens is you have motion out in all directions this way, and then inside, and you get a rotation that starts here or here. And as this wavefront continues this way in this direction in all directions, the rotation continues, and you get a rotation here, and then finally at the ends, I don't know if you can see this, the ends are drawn in, okay, and then once the ends are drawn in, it collides and creates a standing and traveling wave. Here you see collision, sorry, and then here you have standing and traveling waves, and standing wave kind of just like that, and then it's not really a collision so much as it is a communication of wavefronts that are meeting, okay, and once they are able to entangle, they do. And this traveling wavefront, watch, it just travels around, okay, and then back around like this, and then back around like this, and then back around. But conceptually, what it's doing is it goes out, in, and then out, and then in, okay? But physically, it's just going from one side to the other. But what we see in the periodic table is this back and forth difference in the electron clouds. And so the pattern is pretty interesting. What that tells us is that we, in the future, won't be able to create atoms, okay? We'll have to always probably mine and search for materials. We'll be able to use fission and fusion, but to form matter itself is going to be something just beyond our scope, probably for quite some time, as probably unconscionable distances would be required to form the subtle geometries that then would form this autonomous or self replicating structures that then, and basically an atom it evolves out of this collision, all right? Two wavefronts, dynamic wavefronts with standing and traveling waves working through them, create this kind of gyration or autonomous entities or elastic dances. And they're, as the atoms or the autonomous entities are being formed out of this wavefront, in the beginning, there's only one standing wave and one traveling wave that creates the character of the two wavefronts that then interact to form this standing dance. But as the wavefronts make their way back and forth, you get more and more complex wave fronts that are working within these two wavefronts that then interact. Okay, I'm being completely ridiculous in my speech, but there's some mathematics that we have to change so that we can accommodate the physics. You know, mathematics that we do today, it's all over the place. We say that things mean a certain thing without really having an understanding of what we are, what nature is. And so anything goes, you know. But what we do here is that we break down mathematics into things that we need, things that make sense with regard to nature. And I've kind of made a little flow chart here. Here's symbolic language right here. It's like you write on a mark on the wall of a cave. Okay, I say that it doesn't make much difference, or isn't much different than the mathematical physics that we use today. And the reason that is, is because we get lost as humans in those variables. Okay, a variable in nature has two things: character and reference. Okay, this mark on the cave wall doesn't have character and reference. I can look at it and derive something. You can look at it and derive something completely different. You get lost in it. Now, as human cognitive beings, we are looking for two things in a symbolic language. We're looking for, how does it feel? Let's see if I have my, yeah. We're looking for, how does it feel, the texture, and what else can you imagine? We're looking for space or the distance, all right? So if you don't specify two things when you present any variable, someone's going to misreference or not recognize character the way you want it to or want them to, all right? All right, so what we have to do is we have to evolve. And the way we do that, what we do is we look at the physics and we say, what do we need? Well, here, entanglement is created from two things, all right? Two things that find symmetry, all right? Two people or two objects. And then the distance between and that character in each one of those individuals makes up this rate density, okay, or the field, a characteristic field that's produced from nothing, all right, that which is created from nothing, all right. Now, so in an entanglement, you have two variables over here and two variables over here, all right, and they communicate across some distance, all right, so the distance is a new factor. But so when we were to describe, if we were to describe what we need basically to describe entanglements in mathematics, you might say we need four variables, okay? Here, say we have character or cause and effect, or cause prime, effect prime, all right? So if we look at that, what we do is we find something that's pretty interesting. Basically, you could rearrange these four variables, okay, in 24 ways. 4 factorial, 4 times 3 times 2 times 1. That's 24 ways. Now, if you kind of break it apart, what you see is something like this. You see 6 of them are mismatched. 6 ways to reorganize CC and EE. 6 are mismatched in order. 6 are mismatched in conceptual. 6 are mismatched and they're just nonsense. And then you get 6 organizations of these 4 variables that make perfect sense. All right, and describe things in nature. Now, does anything like that sound familiar to us? Yes, biblically, what we see Satan and 666, well, these are kind of deceptions, and that's what we find in the mathematical deceptions. Anyway, so if we start with something that makes sense in nature, in the math, what we do is we make 2 ratios, 4 variables. We're creating an entanglement. But we also want to make sense of the mathematics that we do today. So we start out with a minimum relative value or requirement. Okay, A is to B, C is to D. Okay, you could also say that's like 2 similar triangles. All right, now we have that, two ratios, and we're going to start with that. And we also have the natural relationship of this Pythagorean relationship that defines entanglements or field productions or the character of the fields being produced. So you have an atom that has a certain mass that we measure, it's 10, let's say, and it entangles in this field and it moves at what rate? Well, the rate that it moves, our observed rate that it moves is going to be 10 squared plus some relative distance squared and square root of that. All right, so everything that we see in the mathematical physics today, in our searching, our longing, it kind of materializes in a constant squared. And the reason that is because all the things that we observe are from entanglements, and they contain this Pythagorean relationship where character and distance is formed into a resultant. All right, we may see this may be an observed atomic motion, and this may be the mass that we plug in to an equation. All right, so what we find is that all equations have this ratio times a constant squared relationship. All right, let's do it one better. So what we want is a mathematics that does 2 things that nature does, and I guess I failed to say what this does, but nature then has 2 processes that are occurring: adjudication and comparison. Adjudication, if you look up in the dictionary, it's basically an application of some character over some thing or distance in our case. All right, so we find that in applied distances or applied character, depending on how you're looking at it. Comparison is the other process that we have in nature, and comparison is the way that we find the distances between entangled atoms, let's say. Okay, so our algebra simplifies into 2 processes, not 6, into adjudication and comparison. Adjudication then can be seen as anything that when we're multiplying or dividing or using exponents, we're adjudicating. And in fact, this when we come up with mathematics and we are defining how we divide and multiply and use exponents when mathematics is first developing, I think that intuitively we were trying to find this natural adjudicated process. All right, then comparison in the mathematics has to do with multiplication, or no, I don't know, addition and subtraction, okay? And anytime, it's also my belief that anytime that when mathematics was developing and we're using and developing this addition and subtraction, that really intuitively we are trying to find this comparative natural process where distance is revealed, all right? Because it's eventually going to be revealed in some motion expressed, or heat or something like that. We may not understand things cognitively, but intuitively we are live beings, and we're entangling, we're connected with things, and we don't know ourselves until really we sit down and meditate for a little bit. All right, so the algebra changes to have 2 processes, adjudication and comparison, and we also when we use logarithms, we find that logarithms use those two processes as well, and yet they do them a little bit better. All right, so the equation R over C, reference over character, or reference over structure, times some constant squared, this is found in all equations today, in mathematical physics today, and in the past. All right, let's, instead of constant squared, let's use this log to the cause of effect. Let's see if you can see this. And log effect to cause. All right, that becomes this ratio here. Natural log of E over natural log C divided by natural log of C prime over natural log of E prime times this ratio. Now, this here becomes our minimum ratio that is required in an entanglement. Remember, entanglement has to do with everything in nature. All right. All right. So now we're having to redo calculus itself. Calculus. Well, let's talk about the finite math, and then we'll move to calculus. In finite math, then 0, infinity, and 1. 0, infinity, and 1 do not exist, okay? And the reason that is, we can draw a box around something in nature and say nothing's there, but something's always there. And because entanglements can occur over any distance, infinity is not needed. And 1, because everything in nature is an entangled event, something is not ever 1, it's always 3. 3 things, like a holy trinity, all right? It's 2 locales, and then the distance of that locale that expresses itself into a field that is produced from nothing, or that which is produced from nothing, kind of a God concept, all right? So understanding that infinity and 1 and 0 aren't possible, well, we have to redo the calculus, because that's what we use in infinity, infinitesimal concepts. So we use a discrete integer basis, which is good because everything in nature moves in one velocity, kind of a discrete, all right? One velocity. Things start and they stop. That's it. The reason why we see acceleration, and it doesn't exist, the reason why we see it is called conformations of discrete processes. Our eyes can't process quickly enough and acutely enough, to see exactly what's happening. We kind of just see their overall mix of something that's happening in nature. But anyway, so everything is discrete. So to form a discrete calculus, we find this relationship right here. A function of d plus t minus a function of d minus s over d plus t minus d minus s. All right, now this does the exact same thing as infinitesimal integration or derivative finding, except it uses discrete variables, values. But what's even better than this is you have midpoints, all right, and you have ranges. Now we don't have unspecified change in our calculus. We have measurable change. Okay, we can actually measure exactly what the change is, and we don't just say there's a change. We say exactly what it is. Now let's get a little more fancy and make this integer-based calculus into an exponential or logarithmic form, okay? So that we can process things much faster and better. All right, so exponents take on this integer form here. E to the x minus e to the negative x over e to the x plus e to the negative x. All right, now what is that? That just happens to be, lo and behold, hyperbolic tangent, okay? Right here. And thank heavens it is a hyperbolic tangent. I don't know if you can see that, because the integer or integration of hyperbolic tangent is natural log of hyperbolic secant. Well, what are secants and tangents of functions, you know? They're the things that we want to find, okay? Well, because there was the integration of this hyperbolic tangent is a natural log, yay, we're back here to our logs and the part of the mathematics that expresses itself in those two natural processes, adjudication and comparison, right? Now there's a master equation that we can develop to kind of understand what we're going to do with measuring change in nature, in the environment, okay? And also today, in the beginning, making sense of the mathematical physics equations that we have, you know? Proving, well, we'll talk about proof. Proof is not possible, but making available an observation to scientists today so they can convert to this elastic communication notion or robust entanglement. So what I've done is I put together a master equation, all right? And we start out with an EC, elastic event, all right? Elastic communication, an event, all right? Now, that is expressed in, I don't know if you can see it, I'm doing horrible with the video crap. All right, R of log cause to effect at, not equal sign. We find symmetries in nature, but nothing is equal. It's approximated, all right? It's similar, very similar. And the torsion or the angle that things find symmetries, you know, the angle itself helps to make that field, you know, the same. But nothing is the same in nature, okay? We saw in the evolution here, you know, of atomic or atoms, all right, is built from the system. And as the system progresses, you're producing atoms, all right? So each atom is unique, even of carbon. Even, I mean, utterly, you know, small details are very, very small differences, but they are different. So anyway, we use at, okay, not equals. So we R log of cause to effect at S log of effect to cause. That's our minimum relative value, basically, in a fancy R over S ratio and a fancy C squared. C squared, we saw over here is another ratio, natural logs divided by natural logs, all right? All right, now we take this elastic communication event, mathematical event now, oh shoot, yeah, and if you can see it, twist it. Anyway, and we come here to the integral of I, series of i's over small i's equals function of k to the first derivative over a function of kth derivative. So one more. So now what that is, we're using equal signs there because right there we're piecing together, or we're extracting out of the mathematical equations and the functions that we use today into something that's natural, all right? So the mathematical equations that we have today take this new form, these two ratios right here, all right? And then they make their way into a natural event. When they do, we cancel them out of this part of the equation, all right? Now we multiplied this mathematical equation section by God, G, D, and O. G is gap, D is distance, and O is a Cartesian, but O is also a fancy Planck's constant. Nothing in nature meets back on itself, okay? Everything has some translation. Now the distance that something translates is unique. And this O here in this equation then becomes a species-specific Cartesian, or a robust Planck's constant. And then, and then this D has to do with the distance in each entanglement. And G stands for gap. Now it's this fancy exponential form of the discrete calculus that represents the part of the mathematical equations that makes no sense. Has to do with gap, and gap because it's conceptual. We're missing something. All right. Okay. Now what? All right. So let's talk frankly for a second, and the physics is then describing this entanglement process. All right. Now this happens instantly over any distance. All right. Now, in biology today, what we have come to find and learn about neurons and neural events and thinking and is that there's an action potential that's produced, a a chemical reaction. Okay, but we're missing, of course, the entanglements that are happening. Because this elastic communication is instant, it does allow us to see larger or slower effects, or biochemical, what we call biochemical effects, things like vision, the olfactory, the smelling, and hearing, and touch, and all these kind of things. So and then too, we with this field that's shifting, we develop 2 arms, 2 hands, 2 eyes. Cells in the beginning have electrical charged quality that then creates atomic motion, and then evolution through then. But anyway, so because this elastic communication is instant, it allows us to be prophetic, so to speak. See, time and space is an interesting notion. The theory says that we can travel forwards and backwards in time, but the way you look at it to understand it is perspective. If everything in our field of vision is the size of a piece of paper, okay, to travel forwards and backwards in time, we need to just make that paper larger or smaller, okay? The way you understand proof, because this becomes important here, it's also a religious concept, is that since all things can entangle, if you look at the world from the perspective of an atom, you can never know what it's going to communicate next. So what it's going to do next, you can never, ever know, all right? I mean, you can engineer a box around an atom, and, with 99% accuracy, you can predict and create some atomic motions, and we'll do that. We'll do that to create foreknown forces, to jettison across space, and new craft that we'll devise. But you can never know for certain, and principally or philosophically, then proof is dead. Okay. So I mean, form your proofs in geometry, but when we do that, we're using dimensions that don't exist, 2 dimensions that doesn't exist. We have 3 dimensions. We don't have 21 dimensions. We don't have 13. We don't build dimensions from planes of conception or planes on paper or in topological maps. There are 3 dimensions in time and space. These are man-made notions. Okay, we have 3 Cartesian dimensions. All right, and time, like I said, is a perspective. It's the relative size of that space that you're describing. So anyway, people 5,000 years ago, just by using their own minds and increasing their perspective or their objective 3-dimensional space, by coming into that, thinking into that, you're actually seeing into the future and or past. I think that's probably why you have people that believe in reincarnation, but also the prophetic or prophecies. Philosophers in the past can see kind of what was going to happen or was to happen, and that's what's happening today, where we have this wonderful notion of how nature really is working and will work, and we're going to have a new understanding. Okay, so let's run through some religious concepts. Proof, in religion, they've been telling us forever that there's no proof. They say it's of God, but when we say that God is that which is produced in nature, and we see God in nature, well, then proof is not possible. Now, personally, I believe in God, all right? I believe in a divine being, and the reason I do is because when I pray, and the people that I know when they pray, things happen in mysterious ways, When one time, just to be personal, I prayed after a divorce for God to help me, and the next day, a cross appeared over the back of my pickup truck at the grocery store. Well, no one's listening to me. I mean, that was God. And I've had 10 or 20 other incidents like that. And so I believe in God, and I think you can too. But so I think religion was right on the money when they said that proof is not possible, because it shows it here in this physics and mathematics, all right? The other thing is faith. For me, faith then becomes this process whereby me, as an organism that experiences elastic communication or instant processes, can now watch and understand the slow electrochemical or man-made conceptions, biochemical processes. We can watch ourselves and understand these overt dynamic processes that are occurring in our body. So we develop, rightfully so, this develop of faith. But if religion, organized religion like the Catholics and the Protestants and Muslims, if they would just get off their high horse and describe faith for what it was, there wouldn't be fear mongering and having you support their organization through fear. They would help you, enlighten you on just a natural human process of being able to watch ourselves and find God, and talk to God, learn to pray. All right, so so faith then is this, because we have EC reactions, we have electrochemical, we have two speeds, we can watch. Faith and prayer is important and is then a mathematical physics concept, because it's the activation of our field-producing thoughts. All right, the thoughts that we create are actually creating things that exist in time and space forever, in a perspective forever. All right. Cheat on your wife through thoughts and say it's not sin, and it is. It is sin. Those things that you're thinking are exist in time and space, and religion says that, and I think that we can feel at ease and comfortable and happy that the physics and the mathematics are actually reinforcing these religious concepts like faith and proof and prayer. Anyway, all right, so what else? Let me answer a few questions that a lot of people have. Can we go faster than the speed of light? Yeah. Yes, we can. We can go as fast as any distance that we can incorporate into a produced or engineered rate, density, or field. All right, so if we can use sensors across 1,000 light years away and entangle with something that far away, the rate density in that field produced is going to be the speed with that, or is going to have a speed with that distance incorporated. Now take our engineered capsule and create a systemic conformation or entanglement in that field, and we're suddenly stopped and then start one velocity at that, my gosh, 1,000 times the speed of light at some Pythagorean relationship. All right. Now, will we have to engineer the environment that we put people in? Yeah, and we can do that. We can create entanglements and create the things that we know, like electromagnetism and gravity, and the other strong and weak forces or interactions that we see in and around the atom. Okay. Conservation of angular momentum, conservation of motion, of matter, conservation of energy. Do those exist? No, we already talked about that earlier. When we measure lightning, I think we get 25 flashes per second. So entanglements are occurring at that and then more rate. That's like 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, per second, and 1 yen and 2 yen and 3 yen at each interval. That's a lot. That's a lot going on fast. Now, of course, that's going to give you the notion or conception of a conservation of energy or mass or momentum. Okay, what else? Because since I don't think about all the things that physicists think about all the time, I'm kind of focused in the evolution and development of the math and physics that I do. I don't just come out and refute anything that's going on, but we have basically a Planck's constant that's not correct. Robust Planck's constant helps us to define species of entanglements. Pi is kind of a, it's a two-dimensional concept that doesn't exist, but we have a robust pi that's kind of we use that's kind of the same thing as this Planck's constant. It's this uh, circumference that has a translation in it that's so then it's expressed, and so it's not just pi, but it's a robust pi. Um, what else? I think that's good enough.